5 a.m. I've been up all night. Drank some coffee, stayed up talking with and a new swarm breaking out at the 2.3. Reloaded. Hello, everybody. It is 5:05 a.m. Central Time on Wednesday, December 7th, 2016. And I've got to keep it down. Of course, it's 5 a.m. I've been up all night. Drank some coffee, stayed up talking with everybody over in the Dutch Sense International Italia Terremoto 3D live stream, which is on my backup channel, Dutch Sense Reloaded. Over there talking with some great people, having a good time. And now here we are. We are at the crack of dawn. And it looks like it's going to be another all-nighter. So, that being said, guys, take a look at what just struck in the past couple hours. A deep earthquake down below Turkey, a 2.3. Now, this is deep enough to cause a shallow upwelling pressure, which could be 1 to 2 magnitudes larger. 2 magnitudes larger puts it right where I thought we'd be in that 4-ish range going into 5. Okay, so we were already looking for a 4.8, 4.9 to develop out east of Crete. That's still in the forecast, so that's still what we're watching for. Also, make note of the shallower earthquakes that just struck here in Fiji, 5.0. Additionally, over here in the East Pacific, some 4s struck and a new swarm breaking out at the same spot where yesterday's 6 struck. But get this, guys, they actually upgraded it to a 6. So, what does that mean? Well, again, they upgraded it to a 6 and then they removed it from the feed. But there it is. What else? That is what's going on right now. So, in other words, the spots next to where our deep earthquake struck are being struck right now. Okay? Pretty much everywhere where we had movement last night, there is movement next to it today. North of Japan, 4.0s, 3s and 2s going over into Alaska. Again, I just told you about the 5 down here in Fiji. Also, the 4.9 right on the side of the deep 4.3. So here's our deep 4.3. Here's our shallower 4.9. 4.7 right next to the 6.5. Going up here to the west. New cluster back in Greece and Turkey as expected. And this is going to lead into new activity in Italy today. Most likely by tonight, I should be reporting on it. Our time tonight, so 10 p.m. my time, which is about 4 a.m. in Italy. So 4 a.m. tomorrow. Yeah, so that's pretty interesting. And then also a moderately deep earthquake. I mean, not terribly deep, but moderately deep earthquake below the Adriatic Sea, 3.3. I don't think that's deep enough. Here, let me get the depth on that. Excuse me. I'm drinking my coffee. 77 kilometers. Yeah, that's down in the plate, but not below the plate. So it's moderate. I would call that moderately to not very deep. Okay, it's under 100 kilometers, meaning, again, it's happening down in the plate, along the plate boundary. So there's some plate boundary moving going right now. So, okay, just understand that's going on. Oh, what else? I don't think there's any new volcanic blasts, but then again, I haven't checked in the past few hours, so Maybe I should just quickly jump over and do a volcano check. This is all happening real time, guys. The volcanoes just, flared off yesterday. We were talking about this, how it went from like 2 and 3. Now the list was, I think last night was 7 different volcanoes. Maybe it was 6. But let's go take a quick look and see. Huh. What is this? Pacaya volcano in Guatemala. Activity update. Deep-seated explosive activity. Latest period 2015 into early 2016. Hold on one second. Let me turn on the display capture so you guys can see what I'm looking at here. Okay, Pacaya volcano. They've got a picture of it here. Recent video, no ejections of lava are visible, but rather near-continuous pulsating emissions of steam and ash. Weaker than, but essentially similar to what was seen in December of last year. Magma inside the cone spattering, small Strombolian-type eruptions. Okay, so something's going on at Pacaya volcano in Guatemala. Interesting. Looks like we also have Turrialba, Copihu, and Urta Ale. Where is Urta Ale? Oh, okay, that's just a news. Okay, that's in Ethiopia. Oh. They went down to Urta Ale in Ethiopia, of all places. Are you serious? Okay, here, take a look at this, guys. See where we have our X going down to here? Okay, now this X is, supposedly covering a whole area here. But Ethiopia, right in this region, they went down to Urta Ale, which is, let's see. Let me get it up on a map here. There we go. All right, let's get this up on Google Earth. Okay, see this crater? Obviously, volcano, Urta Ale. Hope I'm saying that right. See these lava flows? Just impressive, like about 100 miles across or more. We'll back this out some more just to show you where it is in relation to Saudi Arabia, okay? So, our X mark is down here, right? Okay, well look at the volcanic range that exists from where we have our X mark, our depositing spot for the pressure that comes over from the West Pacific. Again, that technically puts us down here in Zambia and Zimbabwe. Well, the pressure, the craton pressure, transfers right up to the north, and that's where all of our marked volcanoes are. They don't just stop here, though. They actually exist further to the south as well, into Botswana, Zimbabwe, Mozambique. There's other volcanoes, but this is all, well, I mean, getting out there to study, first of all. Secondly, getting place marks for these is virtually impossible. If they're not on the Smithsonian list, then they're not available for download. It would literally require someone to get out here and do a field study and find out which ones are volcanoes, which ones aren't. That being said, you can imagine them to exist all along the craton boundary in Africa. This goes all the way down to the south. So, anyways, our depositing pressure point down here to the south, up here to the north, up in Ethiopia, going up towards south of Saudi Arabia. Well, if you go in between those 2 points, here, let's get back over here, between the X and between Ethiopia, look where the plate boundary resides. Okay, so we have a breaking arrow happening pretty much right there. And the breaking arrow goes down along the edge of the craton and deposits down here. So we see, sometimes you'll see a swarm happen in the Gulf of Aden, for instance, where this split happens. And then you'll see a follow-up swarm strike down here in Southeast Africa. Again, down near Zimbabwe, south of the volcanoes. Very rarely do we see the volcanoes themselves be hit with any kind of seismic activity. It's usually striking down here. Why is it usually striking down there? Again, that pressure that comes over from this region. And I would dare say we're going to see an excitement here in the next 48 hours now that we saw the 6.5 yesterday and the new swarm today. And Cinnabung erupted. It's going to put lateral pressure to the west. It's going to come right into this region just to fulfill the forecast. And it should be a whole magnitude and a half, well, a whole magnitude less than the 6.5. At the most, it would be a 5.5. Okay? Oh boy, oh boy. So now we got deep earthquakes back over here in South Europe, in Turkey. Look at the progression of deep earthquakes now, guys. Look, I mean, you can see half the planet now has moved on a deep level. Something. And the deep earthquakes are raised high off the globe, so we can really tell. And it's now officially half the planet. From Fiji, across Indonesia, across the Middle East, over to Turkey. From Fiji to Turkey. Look on both sides of the planet. I mean, it's pretty obvious, right? So, what does that mean? It means half the planet has moved at a deep level down below several hundred kilometers deep, several hundred miles. And this deep 2.3, what's our depth on this? 400 kilometers. Well within our deep earthquake boundary level. I would consider anything over 250 to 300 kilometers a deep quote-unquote earthquake. So if it's over 250 to 300 kilometers deep, it is a deep official earthquake, which means there is usually shallow upwelling pressure within 48 hours. 1 to 2 magnitudes larger. Now, 1 magnitude larger, not a big deal, right? 3.3, no big deal. But 2 magnitudes larger, that starts getting us up into a level where it could get, mid-range 4, can cause damage, sometimes even cause small fractures in structures. Nothing to knock down a house, but enough to definitely cause some worry and damage. Oh boy, so we have to watch out for that. Take a look at where the 2.3 is. Look at where our plate boundary goes. Now this red overlay slightly mimics the plate boundary. You can see the plate boundary here. Okay, so the red arrows are slightly offset from the plate boundary so you can see it. And so we follow the plate boundary up and out to the west-northwest and down to the west-southwest, ultimately going out towards the mid-Atlantic ridge. Now it's been quiet up here. It's literally been quiet on the mid-Atlantic ridge. I believe that's all about to change. North Mid-Atlantic's going to pick up here. Why? Progression of deep earthquakes all the way around the entire plate. Okay? So all these deep earthquakes are leading over here to the west, and there hasn't been any shallow, large movement to fulfill that out on the North Mid-Atlantic. But that's the final resting spot. There's nobody that lives up there. Nobody's really going to care, even if a large earthquake strikes up there. And we have seen. Let me give you an example. We saw a 6.8 earthquake strike over here just east of the red arrow in Russia, technically, south of Moscow, or west of Moscow. 6.8. This was a couple years ago. Then, a few hours later, the next day, not even the next day, but several hours later, a 6.8 struck out here on the Mid-Atlantic ridge, south of Iceland, south of our X here. So, what happened? 6.8 struck here, then it transferred to the west and went right out to the area just south of Iceland. How about that? Then, I want to say maybe a year later, it happened again. Okay, there was another round of earthquakes that struck down here on the bend, this S-shaped bend, which was followed up by a 5.6 that struck up here off the coast of Scotland. Off the coast of Scotland. Now, I don't think many people felt it. It was too far out to see. But it was right next to this volcano that is up in. Do you guys know Scotland has a huge volcano up there? Did you know this? Here, you know what? This is interesting. This is interesting. Seriously. Hold on. I found this by accident. Now, I'm sure there's somebody that knows. Scotland Dutch Sense. This should bring it up. Oh, boy. Yeah, this is really interesting to me. USGS and BGS caught red-handed. But we'll go to this one first because this is after they censored the earthquake. They deleted it. After we found what was there, they took it off the maps. But here it is. Okay, so here we go. I could read you my story, or I can just show you the pictures. Either or, because... The hell was that? Something just fell here in my... That was weird. Okay. I don't know what that was. That's weird. Okay. Anyways, so here we are looking at Scotland, okay? And I will read this to you. That freaked me out, guys. Some sound behind me. I don't know what it is. My cats aren't in here. Maybe there's something hitting the window. Okay, anyways, here's our post. So, Scotland, not normally known for its seismic activity, experienced a 5.5 magnitude earthquake. The USGS and British Geological Survey are both ignoring this event, both sites not listing the earthquake. Apparently, they don't want people to know this occurred. And look where it struck. It struck off the coast of Scotland. Here are the statistics from the EMSC, and I gave a link. Let's see if it still works. Oh, no. Okay. Not found. Okay. And I've got a link on that, and it says EMSC has deleted the page as well. Google Cache for it is here. Let's see if Google Cache still exists. Okay, all right. Google Cache is now gone. Well, here's the information for it. Okay, this was again back in 2014, so I'm not surprised Google Cache is gone. Okay, if you check the charts, charts are off during this time or show nothing. So the charts in the area were turned off. This earthquake shows up. It showed up on the feed, guys. It wasn't just, you know, the seismologist page. This actually showed up on the EMSC page. And then I showed the past 72 hours of earthquakes from the USGS, 4.0 and greater. Clearly, the entire region has moved rather noticeably over the past few days. The 5.5 in Scotland is not showing. And then I said, as it turns out, upon review of the location on Google Earth satellite imagery, there's an old dormant volcano at the earthquake epicenter 8 miles away. And this is on land. So I'm going to show it to you, and we'll go look it up. But I've got awesome screenshots here. Okay, you can see the crater shape. Maybe you can't see the crater shape. But, okay, there's the crater shape. And it's not just a strange formation. It really is an old volcano here, guys. Here's another shot of it. It's called the Akanana Volcano Crater. So I found the name of it, the place marks. They've got it marked on there. I mean, people don't normally think of Scotland as a spot, and look where the earthquake struck in relation to the volcano. Well, let's wait for this to load here. There we go. Out to sea by several miles, 5.5 earthquake. And it's at 56.70 north. Here, let's look it up. 5670 north, 6.39 west. 56 north, 6 west. Okay, here we go. Now let's zoom in on the area a little bit and see. Oh, there's other areas that are volcanic nearby, by the way. But let's see where it. Oh, that's not it. Did I get that right? .56 north, 6 west. Ako Snitch. ACHOSNICH. Okay. There we go. Akonich. Oh, Akonich. United Kingdom. Well, how did we get that location off? What is this? That can't be right. Glad I looked. What is this? How can that be? This makes no sense. They're both listed at the same coordinate here. Let's just make sure. Look at this. Look. Look, guys. Look down in the lower right-hand corner, man. 56 north, 6 west. 56 north, 6 west. That is wild, man. It is taking us to 55.5. That is too weird. It's taking us to 55.5 when you search 56 north. When you search the volcano coordinates, it takes you to 55.5. Oh my god, it takes you a whole thing off. You gotta be kidding me, man. Alright, well, okay. Here it is, guys. Here it is, right here. Oh, I can't believe that. That's deliberate. That is deliberate. They don't want people to see it. Okay, we're going to turn on the photos. Now, these are placed by the Google Earth community, so you know I'm not, putting it here. Volcano crater. Of course, that's misspelled. Oh, Panorama is closing now. Dang it. Okay, well, not a problem, guys, but now you can see it. So other people have marked it as volcano crater, not just me, and you can go look up the history on it. The Achnaha, Achnaha. They'll probably have some creative thing for it. Ah, here it is. Oh, look, it's got a Wikipedia. I mean, I don't normally read Wikipedia, so let's skip Wikipedia. Let's go to... Okay, well, obviously they've got a whole description of it here, so it's not a hidden secret. The term impact crater usually refers to the result of hypervelocity collision of a smaller body on the surface of a larger one. On Earth, most of the cratering record has been erased because of the tectonic processes and weathering. The cratering of the Moon shows nearly a complete record of impact. It was first surveyed in 1932, the era of Ardnamarakan has been of great interest to scientists all over the world who come study its remarkable cratering record. The Earth's tectonic plates, which make up the outer layer or crust, are constantly moving, colliding and dipping under or over each other. BS. Some of these collisions have formed great mountain chains, one of which, Himalayan range, included all of the current Scottish highlands millions of years ago. Today, the roots of these ancient mountains remain. The Ardnamurchan Peninsula was far enough away from the main zone of deformation of these ancient mountains to have preserved a record of the land's upheavals and burials. About 65 million years ago, a plume of molten material known as a hotspot that had been slowly rising from deep within the Earth reached the surface. When it broke through the crust, a series of volcanic eruptions began, which lasted for 3 million years. Although weakened, the hotspot has remained active after North America and Britain have drifted apart. That's BS too, guys. and to this day is still forming the volcanic landscape of Iceland. They've got it all wrong. When a large ice sheet began to cover the Earth, their advances and retreats caused much of the Argonauts' ancient volcanic landscape to be ground away by ice, leaving today's raised beaches and rounded hills. What has fascinated scientists about the geology of Argonauts has an ancient caldera, although some geologists feel the term caldera may be inaccurate. So let me just stop right here, guys. I kind of don't want to read any further about their explanation because they've already premised like so many incorrect things that we've debunked now. For instance, that any of this was, these rose out of the sea. Europe, Africa, Asia, rose out of the sea. These never moved and were never connected. You know how we know they were never connected? Because Iceland's always been there. Okay? Like Iceland rose out of the sea, guys. So that means Iceland never was connected to these areas. And not only that, if Iceland rose out of the sea and hasn't moved, then these same undersea seamounts also rose out of the sea and haven't moved much. Now the magma maybe underneath has moved, and that's caused new islands to form in kind of progressions, but the plates themselves are actually locked. They're, accretionary ridges piling up on top of each other, fracturing due to pressure. So they got it all wrong. All of it. And that explains why they could... Okay, so anyways, let's really explain the volcano there in Scotland. You guys want a real explanation? And this is just coming off the, tip of my hat, so to speak. And it's formed, and it's, first of all, it hasn't moved. Okay, so it's been there for a long time, and it will continue to be there for a long time. There is no evidence that it's moved. There's no volcanic chain to show that the magma spot has changed. And the plates haven't drifted apart at all because it's in the same spot. Okay? So, simple logic, right? It's in the same spot. Well, if you take a look out to the west, you're going to see a few things that should stand out to you as rather odd. These are not sinkholes. Okay? Don't mistake this for a sinkhole. That's how many miles across? Let's get a measurement tool on this. Okay, that is 26 miles across, and it goes, let's see, it's a dome with a small crater at the center, which means most likely it's volcanic in nature. Not talked about much. Several of these must be covered in seamounts, but we do have crater marks and pocks as well as undersea mounts that are conical shaped, meaning volcanic is there as well. So what does it all mean, guys? Well, it means this has never moved much. It's been there for pretty much the entire portion of the time that the plates have risen out of the sea. The only thing that's separated the plates is water. They got it all wrong. Here's another way you know they got it wrong. Okay, we can zoom in on the ridges here on the Mid-Atlantic Ridge. Okay, you see these north and south ridges? Now, scientists have incorrectly assumed that these north and south ridges are somehow formed by lava that comes up and out of the Mid-Atlantic Ridge somehow and forms these ridges that then spread out and push the plates apart. Well, that would be great, fine, and dandy if two things didn't happen. One, that there weren't volcanoes mixed in here, seamounts that have risen over time and have stayed put, and two, if there was evidence of an actual lava field of some kind. We don't have evidence of either. Instead, we have back and forth facing ridges north and south, right? And a scientist assumed that that's due to growth. Well, what we're finding out now is this is most likely these north and south facing ridges are due to accretion, pressing together, like pressing a tablecloth together. You get multiple ridges that form up, okay? Depressions and ridges, accretion ridges, build up. And to prove that pressure is coming in on both angles and sandwiching this together, not growing apart, are our east and west fracture zones that you can see here going east and west. So we have our north and south accretionary ridges, and we have our east and west fracture zones. And the fracture zones have always been there. There's no evidence of those moving either. Now there's spots where there's slip that's occurred. Here on the fracture zones, you can see where this used to meet up with this over time, which means this whole section has slipped. Pressure, more pressure coming from, let's say, Central America maybe, or from Africa, either or, pushing and causing a slip and a break on the mid-Atlantic ridge. And it's happened many times. So you can see these east and west fracture zones have always been there, or at least have been there since the formation of the crust of the planet, which totally defies all of the theory that these plates were all connected and have moved apart and switched around. And you would have to add a ton of time, and I mean billions of years, to the age of the universe to allow for all these plates to move like they say they moved in order for them to be apart as far as they're apart. In other words, the plate tectonic movement would have to have been much greater, or the age of the universe would have to be much older. Which is it? Neither are possible. Actually, the age of the universe, that's up for debate. But, on this being connected, no evidence of it. The geologic column doesn't match on either side. The only thing that matches somewhat is the shape, and that could easily happen if they're being pressed together. Especially if the point where they're pressing together is a fracture zone that's shaped in the same shape that both sides are shaped in. Think about it. The middle point is the fracture zone, where it's been pressed together and ridges have formed. Well, as this is pressing over a long period of time, it's going to take the shape of the ridges. The ridges here form this shape, and then, of course, that dictates the shape on both sides. It's a happy coincidence that they're both taking that shape. Okay, the rest don't match up at all. Only a few, again, areas where water has come in and filled in the lower depression areas that you can clearly see were connected as plateaus at some point, much like what we see down in Nevada, let's say, where all of our mountains come up out of an area that used to be connected by water. This all used to be filled with water, and I can imagine that this looked somewhat like this up here. The multiple island chains and the mountain chains that stick out of the water. Now, the formation, I believe, happened the same way, guys. It's just environment that's the only difference here. So, again, I think it's all been gotten wrong by professionals, and we're going to see. I mean, the proof is in the pudding. You guys can make it out for yourself. You can trace the lines. You can follow the earthquakes yourself. You can, again, see that the plates formed in a different way than we've been told. And I'm not trying to confront too much in geology, but I'm just telling you that we have basically proved a lot of what we know in modern-day geology to just be entirely hogwash, like made-up suppositions by people. I mean, it's okay. That's the way it was done. It was ideas by people that are reviewed by other people who are either friendly to them or at least friendly to the process, trying to push an idea or agenda to get science going. I mean, that's the way it's done. Your ideas, but the problem in science is that people's ideas that get pushed get accepted as blatant fact when they're not. And that's when people become entrenched in their dogmas, and that's what I've been fighting here against. So, the evidence is showing that the plates weren't connected. The evidence is showing that the plates are being pressed together. The evidence is showing progression of earthquakes across distances. Well, never mind the evidence. We've got a dogma to hold, and so we're finding that there's a conflict happening in science over this topic in particular. So, anyways, there we go. Just keep watch. It looks like a new swarm is breaking out southeast of the 4.4 from yesterday in California near Clear Lake Volcano. And that's a geothermal pumping operation. Oh, it's going to be another busy day. I better just drink up my coffee and do my thing. Much love, tanto amore to everybody over at the Dutch Sense Italia room. I'll be back on in a little while.